Okay, chapter 4. This is probably one of the most important chapters that you're going to cover. It sets a foundation for the rest of the semester, and it is talking about molecules and compounds. We're going to learn how to put them together, we're going to learn how to name them, and so forth. Okay, so we have talked about elements, the elements from the periodic table, but we haven't really talked about molecules. Molecules are when you have two or more elements that combine. So it could be H2O, it could be CO2. Those are just examples. So here, this is water, right? And water is H2O. So we have a combination of hydrogen elements and oxygen element to put together, and we get a compound. Now, we can put elements together that are the same, and when that happens, like you see here, we call that a diatomic. So I'll spell that for you. Diatomic molecule. A diatomic molecule is when you have two elements that are the same that are bonded. Now, your halogens, oxygen and hydrogen, in nature are diatomic molecules. Okay? But they don't have to be the same. Elements can be different, just like we see in water. All right, when we put our elements together, they're going to combine. They're going to combine in whole numbers. And when they combine, they make something completely different. So for example, let's look at hydrogen and oxygen. We know hydrogen, for example, here we see just hydrogen exists diatomically, so this is H2. Look at the boiling point. It's a gas, and it's extremely explosive under normal conditions. Oxygen is also a gas. It's also diatomic, has a very low boiling point, and it is often used in combustion reactions. If I put those two together, I get water. I have a huge difference in boiling point now, and now it's a liquid, and now it's not flammable, so it actually can be used to put out flammable things like oxygen and hydrogen. Whenever we put together a molecule, it follows what we call the law of definite proportion. And that is that the proportion of your elements in a molecule are always going to be the same. Meaning water is always going to have 2 hydrogens to every 1 oxygen. That's the law of definite proportions. So water will always be H2O. So that ratio that you see here for water will always be the same. If I have ammonia, which is NH3, ammonia will always be NH3. It'll always be 3 hydrogens for every 1 nitrogen. There are 3 types of chemical bonds that put our elements together in order to make a molecule, and they are ionic bonds, covalent bonds, and metallic bonds. We're really not going to spend much time talking about metallic bonds, but we are going to talk in detail about ionic bonds and covalent bonds. Bonds are how our molecules are held together, or how the atoms are held together to make our molecule. These 2 type of bonds, they're done differently, and I'll give you a preview on this. Ionic bonds are formed between a metal and a nonmetal. Covalent bonds are formed between 2 nonmetals. And we see an example here. So this sodium chloride, NaCl, sodium is a metal, chloride is a nonmetal. It is held together by an ionic bond. So metal and nonmetal. Water is 2 nonmetals. Hydrogen's a nonmetal, oxygen's a nonmetal. Water is put together by a covalent bond. So 2 nonmetals. We're going to start by talking about ionic bonds. An ionic bond, again, is a bond that's formed between a metal and a nonmetal. And how it's formed is there's a transfer of electrons. Now, we'll talk about that in detail here in just a minute. But what happens is our metals and our nonmetals work with electrons differently. Your metals, they lose electrons. Okay, so let's go ahead and write that down. And your nonmetals, they gain electrons. So what happens is your metal loses an electron, one or more, to the nonmetal. And with that, it forms what we call an ionic bond. Now, when a metal, like sodium, loses an electron, it takes on a charge. And in this case, it takes on what we call a +1 charge. So it forms a sodium ion. Whenever our metals are charged, that is called a cation. Positively charged ions are called cations. Your nonmetals, they gain electrons. Like I have chlorine, and it gains an electron, it takes on a -1 charge. Negatively charged ions are called anions. How do I know how many electrons they are gaining or losing? So we'll talk about that more in a minute, but let me show you this. So if you look at sodium, sodium has 11 protons. The sodium atom has 11 protons and 11 electrons. We know it's a metal, so it's going to lose electrons, and sodium is only going to lose 1. So if I lose 1 electron, then I have 11 protons and 10 electrons, which gives me an overall charge of +1. Well, chlorine has 17 protons, there's a chlorine atom, and 17 electrons. Because chlorine is a nonmetal, it's going to gain electrons, and in chlorine's case, it's going to gain 1. So I have 17 protons and 18 electrons, giving it an overall charge of -1. That's where that 1 comes from. Okay. All right. Covalent bonds. This is a bond that is formed between 2 or more nonmetals. These bonds are not formed by losing or gaining electrons, but rather it's formed by the sharing of electrons between 2 atoms. When we have 2 atoms that are covalently bonded, we refer to that as a molecular compound. Whereas when 2 atoms are ionically bonded, we call it an ionic compound. Now, either way, we're going to represent our compound with its chemical formula. The chemical formula indicates the type of bond and the number of each element present. For example, the chemical formula for water is H2O. There's 2 hydrogens and 1 oxygen. Carbon dioxide is CO2. There's 1 carbon to every 2 oxygens. This here is a covalent, they're covalently bonded because they're all nonmetals. Same here. Here we have an ionic bond between sodium and chloride. And then here, carbon tetrachloride is CCl4. There's 4 chlorides attached to this carbon. And that is what type of bond? It's a covalent bond because these are all nonmetals. Now, our chemical formulas can be represented in 3 different ways. We can look at the empirical formula, the molecular formula, and the structural formula. Let's talk about the differences. The empirical formula gives the relative number of atoms for each element. So this is their simplest ratio. For example, if I have carbon monoxide, the empirical formula is showing me that I have 1 carbon for every oxygen. If I have, let's pretend that this is a thing, I have C2H2. Okay? This is not this structure's empirical formula because it's not its simplest whole number ratio. This empirical formula would be CH, because that would be the simplest ratio comparing these two. So for every 1 carbon, I have 1 hydrogen. Now, for this one, that would actually be the molecular formula. The molecular formula gives the actual number of atoms of each element in the molecule. For example, let's look here, I have C4H8. That's not the simplest ratio. So this here is the molecular formula, but the empirical formula would be CH2. So divide each one by 4, that's your simplest ratio. Here we have B2H6, not the simplest ratio, but that's the molecular formula. Its empirical formula would be BH3. Now here for carbon tetrachloride, this is the molecular formula, but it's also the empirical formula because I cannot simplify this ratio anymore. The structural formula, this is just a sketch of how things are put together using lines to represent bonds. In this case, we're talking more about covalent bonds. Like, for example, water is oxygen bonded to 2 hydrogens on each side. So this would be its structural formula. Okay, let's do these. Write the empirical formula for each of the following. So we actually did these 3 already, so let's look down here. C5H12. Can I simplify it? The answer is no. So this would actually be the empirical formula as well as the molecular formula. Mercury chloride. Can I simplify this? Yes. So the empirical formula would just be HgCl, because I can simplify this by dividing by 2. Here's the molecular formula of this compound, C2H4O2. Can I simplify it? I sure can. So I have CH2O. So this would be the empirical formula. All right. So just to look at the overview again, the structural formula tells us what's bonded to what. It's a visual picture. The molecular formula tells us the actual amount of atoms in the compound. Doesn't tell you how they're bonded, but it tells you how many you actually have. And the empirical formula just gives us the simplest ratio between atoms. The empirical formula doesn't tell us a whole lot. All right. Now, there are other ways to view our compounds, 3D representation. So we have the molecular model, the ball and stick molecular model. And if you look here, this is just color coding. I'm just going to give you an example. So this is methane, CH4. So here's the molecular formula. Here's the structural formula. This is the ball and stick model, so it actually shows a little more geometry. And then this is just showing what area of space that it's all coming together. Here's just a couple more of those examples taken from the table in your book. Okay. Now, we're going to move on to what we know as the octet rule.